Hello, I'm Greg Nichols, a subject matter expert with the Homeland Defense and Security Information Analysis Center. And today we're talking about bone regeneration, what it is, how it works, and why the Department of Defense is interested. Over 6,000 soldiers deployed to Iraq and Afghanistan have sustained musculoskeletal injuries, with more than 40% of these injuries being fractures, as reported by Belmont et al. In 2016. Primarily, this is due to the higher incidence of explosive blasts in these conflicts, which account for greater than 80% of all musculoskeletal and orthopedic injuries incurred. Blast-induced fractures are especially bad for three reasons. They are devastating injuries that can influence mobility and function for life. They are often associated with infection and chronic pain, and they are difficult to repair, and improper healing occurs when not treated immediately. One way to solve the challenges of blast-induced fractures is through bone regeneration. Let's take a look at that process. An external force causes a bone to break and results in a fracture. A scaffold made of a biocompatible material is inserted in the gap left by the fracture. The fracture triggers the recruitment of cells that help build new bone. These cells attach to the scaffold and begin generating new bone tissue. This process continues until the bone fracture is repaired. DoD supports a number of bone regeneration research efforts. One of the most exciting DoD-supported technologies is the NuCress Scaffold, a bone regeneration device developed by a multi-institution team. NuShores Biosciences holds the exclusive license to the technology. Dr. Alex Bierus at the University of Arkansas Little Rock led the development of this bone filler, an implantable device designed specifically to help heal complex major bone gaps. For over a decade, Dr. Bierus has partnered with Dr. David Anderson at the University of Tennessee, Knoxville to improve and advance the scaffold. Recently, we sat down with Dr. Anderson to discuss the team's promising results.
I'm Dr. David Anderson. I'm the department head of Large Animal Clinical Sciences at the University of Tennessee College of Veterinary Medicine. I'm a professor of surgery and a faculty member in the Veterinary Medical Center at the teaching hospital. One of the reasons that we got into doing what we were doing is because there was such a high rate of amputation associated with battlefield injuries that we felt that we might be able to make a difference there by enabling the bone to heal by bridging it with some type of scaffold material. And so the idea was to fill in these tremendous defects and provide the bone a lattice work upon which it builds new bone. And so the three-dimensional scaffold that we've developed now, which is called NuCress Scaffold, and NuShores Biosciences has the licensing rights to that technology. It's a combination of a polymeric skeleton that has nanoparticles of hydroxyapatite suspended in it, and then we blend bone particles throughout that three-dimensional matrix. So it literally, if you think of it as a coralline type structure or a sponge type structure, it creates a highly porous material that allows cells and blood vessels to very quickly invade into the scaffold. All of our studies to date have been focusing on problems in the long bones, and so the different bones in the body have really different physiologies, and they respond to things very differently when they're healing. And so two of the body areas that we're looking to translocate or to translate this technology into is the craniomaxillofacial area and dental restoration. Mandibular injuries and maxillary injuries are really, really common, and so trying to help rebuild faster, more functional recoveries of those tissues. The other one is spine. There's continues to be a huge challenge with spinal fusions and getting patients back to comfort without morbidity. And we think that this technology could be transitioned from long bone into spine fusion. And so we're talking with neurosurgeons about the potential applications for the device there. So one of the things that we're most passionate about with this technology is the ability to help people. And the Department of Defense is very engaged in trying to ensure quality of life and sustainability of high function. And so one of the things that we were trying to do with this device is to help injured warfighters return to normal life, whether that's pain-free life or back to normal function or improve function. And so there's some really challenging injuries that occur in the battlefield. There's some really challenging injuries that occur in the intensive training that soldiers need to do to be prepared for what they're asked to do. And our intention with this technology is to try never to allow an injury to prevent them from having a fulfilling normal life. And so if we can help people by healing injuries that unfortunately occur as a result of conflicts that occur around the world, that'd be extremely gratifying. And if we could save one person's life or save one person's limb that couldn't be saved before, it would make everything we've done in the last 10 or 15 years worthwhile.
DoD is supporting bone regeneration research at other universities as well. Let's take a quick look at some of it. In 2017, the University of Pittsburgh received a grant for over $2 million from the DoD to continue development of an off-the-shelf biologic device to promote bone healing that could be loaded with stem cells directly at the point of care. A research team led by the Houston Methodist Research Institute is developing a scaffold that uses an outer load-bearing shell composed of a biodegradable polymer called PEU and an internal shell made of biomineralized collagen. Finally, the James Laboratory at Johns Hopkins University receives DoD support to research bone tissue engineering and novel growth factors that speed bone repair. In addition to bone regeneration research, DoD is currently investing in some other related areas. In 2017, DoD opened the Advanced Regenerative Manufacturing Institute, which focuses on making the large-scale manufacturing of engineered tissues and tissue-related technologies practical. Looking forward, DoD is working with NASA to study bone healing in microgravity environments in order to learn how healing in space may be applied to combat casualty care. They're also investigating the possibility for total limb regeneration in humans, which is definitely future-oriented and out-of-the-box thinking. DoD researchers are studying regenerative mechanisms seen in certain animals, such as salamanders, and attempting to recreate those same mechanisms in humans. The ability to one day regenerate an entire limb would eliminate the need for prosthetics and extensive wound healing. Thanks for joining us today. To learn more about these bone regeneration efforts, check out the HDIAC website and don't forget to follow us on social media.